Hello students, hope you are doing well. So today in this video we'll continue with the same chapter, that is surface chemistry. So in the last video we studied about adsorption, the different components of adsorption, different types of adsorption. We also studied about the different factors which affect adsorption. In this video we'll start with French adsorption isotherm. Now, isotherm means at constant temperature. So, this topic, this phenomena is to be studied at constant temperature. So, according to French adsorption isotherm, the adsorption is related to the pressure at constant temperature by this equation. X by m is equal to K P power 1 by n, where the value of 1 by n ranges between 0 to 1. X is the mass of adsorbate, m is the mass of adsorbent, and X by m represents adsorption. K is a constant, P is the pressure. Now from here there are three possibilities. First possibility, at high pressure. At high pressure, 1 by n is equal to 0. That means adsorption, that is X by m, is equal to K P to the power 0, which means X by m is equal to K, that is constant. So at high pressure, no matter how much pressure you increase, the adsorption will remain constant. At low pressure, 1 by n is equal to 1. So in that case, X by m, that is adsorption, is equal to Kp. So at low pressure, adsorption is directly proportional to pressure. That means if you increase the pressure, adsorption also increases. And at intermediate pressure, that means it's neither high nor low, 1 by n ranges between 0 and 1. So X by m is equal to K P to the power 1 by n. Graphically, we can represent, if we take adsorption along y-axis, pressure along x-axis, we'll get this kind of curve. So you can see, initially when the pressure is low, adsorption increases sharply with increasing pressure. At a certain point, the increase is intermediate, and from here, no matter how much pressure you increase, the adsorption remains constant. So French, he studied the change in adsorption with respect to pressure, and he found out at low pressure, if the pressure is low and you are increasing the pressure, with increasing pressure the adsorption will increase sharply. After a certain range of pressure, that means at intermediate pressure, the adsorption increase will slow down, and when the pressure is high, the adsorption will remain constant. So this is the French adsorption isotherm equation. So we have one more equation for French adsorption isotherm, which we derive from here. So let us see the next equation. X by m is equal to K P to the power 1 by n. We'll take log both sides. So log of x by m is equal to log of Kp power 1 by n. Now we know the log formula. If you have log AB is equal to log A plus log B. So we'll apply this formula here. So it will be log K plus log P to the power 1 by n. Or we know if you have log A to the power B, we can write B log A. So using this formula, log x by m, that is adsorption, is equal to log K plus 1 by n log of P. Now this equation is in the form of y equal to mx plus c, where y is log x by m, x is log p, m, which represents slope, is 1 by n, c, which represents intercept, is log k. So if we draw a graphical representation for this equation, taking log x by m along y-axis, log of pressure along x-axis, we'll get this curve. This is known as intercept, which is given by log k. And if we calculate the slope for this curve, the slope is equal to 1 by n. So you might be asked, you'll be given this equation, you'll be asked, what is the slope of the equation, or what is the intercept? So you need to know this equation also. So in exam, if you're asked, write down the French adsorption isotherm equation, you need to write both the equation. You write x by m equal to k p to the power 1 by n, and then you derive the equation and you write this equation also. So this is your French adsorption isotherm. Next, we are going to start a new topic, that is colloid, true solution, and suspension. Now, colloid, true solution, and suspension, they are classified based on the size of the particle. In case of true solution, the size of the particle is less than 1 nanometer, or we can write 10 to the power minus 9 meter. So in case of true solution, the size of the particle is less than 1 nanometer or 10 to the power minus 9 meter. In case of suspension, the size of the particle is greater than 1000 nanometer or 10 to the power minus 6 meter. So in case of colloid, the size of the particle ranges between 1 nanometer and 1000 nanometer. So true solution, size of the particle is less than 1 nanometer. Suspension is greater than 1000 nanometer. Whereas in the case of colloid, the size of the particle is between 1 nanometer and 1000 nanometer. So we'll study colloid in detail. So colloid has got two components. The components are known as dispersion medium and dispersed phase. Say you take water, and to this water you add gold particle in the colloidal size. So the water will act as dispersion medium, whereas the gold particle which is added to the water is known as dispersed phase. One more example, say you take water in a larger quantity and add milk in lesser quantity. So in this case the water will act as dispersion medium and the milk will act as dispersed phase. So dispersion medium, we can say the substance where the colloidal solution is prepared, and dispersed phase, we can say the particle which is added to the dispersion medium to form colloid. So the two components of colloid are dispersion medium and dispersed phase. So next we'll study classification of colloid based on different factors, like based on nature of interaction between dispersed phase and dispersion medium, based on the physical state of dispersed phase and dispersion medium, and the third factor is based on the particle of dispersed phase. So we'll start the classification in the next video. Thank you.